Wow. Okay. This was a tough one. So we're given this XY graph. We're given two equations for our curves here, and we're looking for X bar and Y bar. We're going to use these two given equations that you gave us in the notes. First we're gonna do area. So our bounds are 0 to a, which are given along this x bound. So our x bound is 0 to a. It's the integral of the top curve minus the bottom curve. And we have a lot of variables here, which we don't like. So we have to derive m and k. M you can do graphically pretty easily.
Oh,
but
is
you can
M
also
just a slope?
Yeah.
Oh my god.
Oh.
Wait, no, I'm actually realizing this.
And but you can also plug back into our original equations here and rearrange to solve for m and k. That's a little easier than trying to figure it out with the graph. And then you got yourself a 20C problem. So then we're going to plug in and solve. Eventually we'll sub in k and m. That'll give us a simplified answer of x bar is equal to 2/5 a.
So how did you know when to sub in for them? Is that just after you finish the integral?
Yeah, you got it.
Okay. That makes sense.
very
Because while you're doing
astute.
the integral, I guess you could sub in earlier because they're just constants, right?
Yeah, but
It just makes
it's not like it doesn't make your integration any harder. To
Yeah.
lead on to.
Okay. Then no, that makes sense.
This made the most sense.
Because I think I was overwhelmed when I was trying to set up the integral. Like there was like 20 different variables, and I just wasn't like. It's hard to tell what's constant and what's like.
And it definitely looks scary. And then for y bar, we're essentially doing the same thing, except for the y, of course. And eventually we'll plug in, this k and m are also derived from plugging into the original given equations, or slopes. And you should get 1/2 b for that. So yeah, not too bad actually once you start working with it. It took me a while, but we got there.
How long did it take you?
Dude, it was like 40 minutes at least. Thank you.
All right, should we give her a flipper, Rooney?
Yeah. Wait, did Case want to do his?
Oh yeah. My bad. I'm sorry about that.
Alright, I'm Case. I'll be doing problem 1. Contrary to promises, like astronomically hard problem. This one's actually really simple once you just like take a look at it in a different light. So we have a system with 2 blocks on an incline connected by a pulley with a string and tension. And we have 2 separate body diagrams for it, each with their respective forces. So using 2 systems of equations, one for each different diagram, we can actually get the delta fx and y equations. Noticing we have t's in both of them. So using that, we can actually isolate the t in both equations and set them equal to each other and have an equation just in terms of theta. So once we isolate theta, we just see it that it's 37.23 degrees.
So the tension is the same from this block and this chord to this block and this chord.
That's true. They're just in different like numerical values.
Now
based on
we're starting
forces.
to combine like a week 1 stuff now with the current.
Yeah. This is like AP physics stuff.
And 2A, definitely, I remember that.
So how did you know which directions to do like the friction? Because I was thinking like, if it's in equilibrium, like how do you know where the friction's going?
So initially, it actually gives us that there's no friction between this block and the incline. So
It's
we know
only
there's no
held
friction.
up by the pulley.
That's true. And the friction between the blocks, we know that this block up here is actually heavier, so it'll be sliding down.
So like if it
friction
wants to
opposes
move,
motion.
the friction is the opposing that. So in
Yes,
order for
yes,
it to
yes.
oppose that, it needs to be
So
opposite.
we know it's this
Okay,
way.
yeah.
And I know they asked for 2 different free body diagrams, but this also means like we can treat each part as a separate system, and then that's why we calculate the difference.
That's true.
the X
Exactly.
and
So
Y
ideally
coefficient.
on the test, we need to know to do that by ourselves.
Because if you did it as a whole system, there's too many variables.
Yeah, I don't know if you could be able to solve with just
Yeah.
one system. Because there's
Okay.
not enough equations for the unknowns, you know.
Yeah.
Now we have enough unknowns, enough equations, we can isolate them.
Sweet.
And then also for your free body diagrams, I noticed that the blocks are on an incline, but your free body diagram is not. What's up with that?
Yeah, so it's just a personal choice. You could do it like normally, but like I just set my axes to be parallel to the blocks.
Oh, so those
perpendicular.
dashed lines are your new
Yeah.
axes.
So these are the axes I made, and then
Oh my.
it eliminates all
Oh,
the
yeah. Takes out a lot
angles
of
except for
angles.
these ones, and it's much easier to solve.
Very nice.
Yeah,
Very nice.
that's it.
Thank you.
All right, perfect.
Excuse me. All right. So in the black here, we have, this is the second problem. We're given this system of 2 blocks and then 2, I don't know what you'd call this. They're connected by a joint at point C, but it's like a little bar right here. And then there's an applied force P, which we're going to solve for in terms of the weight W, which is not unknown, it's just a variable. So first we're going to split this up into 3 different systems, kind of similar to the last one. So we're going to have block A, block B, and then the joint C. In their respective free body diagrams, these are pretty similar, pretty straightforward. So then we're just going to go ahead and set up our delta Fy and Fx. This should say Fx with respect to A. But I just set up the ones for A. It's the same for B. So once you set up your delta Fy, you can go ahead and isolate for the normal force with respect to W and FAC. And then if you do delta Fx for box A, we can get the friction is equal to the FAC, and then the component. This is a 30-degree angle, by the way. I should have drawn that on the diagram. Do you have a marker? Oh, thank you. So this is 30 degrees. And then we'll derive that we know that they gave us the coefficient of friction is going to be 0.3. And so we know that friction is going to be equal to the coefficient of friction times the normal force. So we can go ahead and turn that and get rid of an unknown. And now we can plug back in for our other normal force and get FAC in terms of W. So you're going to do the same exact approach for this one. It's the exact same, just a little bit different angles and whatnot. I believe this is like 60 or something. And then you'll get this also in FBC in terms of W as well. And then if we go ahead and look at point C over here, we can go ahead and set up a free body diagram and do a delta FC, and then combine everything from over here, plug this in, and then we'll get P in terms of W. Something to note is that if you're taking the delta Fx, you could solve for it in terms of Fx or Fy, but since the problem asked for, was it the maximum?
Yeah.
The maximum force, we're going to do the Y, because if you notice the majority of this, I believe this angle was 30.
10.
Is it 10? Oh, my mistake. Yeah, this was 80. Sorry, yeah, this is 10. So a vast majority of it is going to be in the cosine direction, which is our delta Fy. So we're going to take the delta Fy to find the maximum. But yeah. Any questions?
No, that maximum thing that you just explained actually clarified. I was wondering that.
We'll explain. Because I think a lot of people will take the delta Fy and then they'll get an answer that is correct and not realize that there was even an option to do it incorrect by doing the delta Fx. Like some people might intuitively realize that, or you might just do it by chance.
Yep.
Which is what I did at first and then kind of realized.
If you use this intuition too, it also saves you time and calculation.
So true. Intuition will always save you time. All right, should we move on to number 5? Sorry, I kind of took up the whole board. Also, number 7 right here.
We can get to that later.
Okay, we'll get to 7 later, but let's do number 5.
All right, so for this problem, we're trying to locate the centroid along this plane, and we're given some length values. So we have a half circle here with a radius of 38 inches, and then this box that's been cut out of it. So it has a width of 20 and a height of 16. So ultimately what we're trying to do is get all the values to get the x coordinate, I guess you would call it, and then the y coordinate.
X bar, y bar.
And so the easiest thing you could solve for first with these values is the areas. So we'll take the area of the circle, which is just 1/2 the area of an actual circle, because we only have half of one. And we'll get 2,268, and then we'll do the same with the box and get 320. And as the formula says, we're trying to get the sum of it, so we'll just subtract, because this is like missing from the circle, so we'll subtract the 320 out, and we'll get a summed area of 1,948. So we have our denominator now, and we're going to get x bar and y bar next, and those are found through, I didn't write the table down, but there's like a table of equations for that. So we'll get that x bar is 10, and here's the plug-in for y bar. That'll come out to 16.13. And then we take x bar and multiply it by the individual areas, not the summed area. Plugging that in for the x coordinate, we'll get 1.64 inches, and then for the y coordinate, we'll get 17.46.
And we're not subtracting anything here because the X bar component for the semicircle starts at this axis, so it's not moving any.
Yeah.
Okay.
Because if you take it at this axis, this is the center, and if you look at the x component, the center is at 0, so it's going to cancel out, and that's why you're not seeing a subtraction there. So you could do it with respect to over here. It's just more work.
Okay.
And I'm not entirely sure. I could be totally wrong about this, but I think the reason that we subtract the 8 times 320 here, I think that's because we've subtracted like a section.
cut out.
Is the area of the box, is that supposed to be negative? Because it's like negative area from the thing? That's
Well,
what I thought of it
it
as.
kind of is a negative because if you look at here, he subtracted the 320 from this.
Oh, he did. Okay.
Yeah,
Yeah.
so to
I
get the
see, I
total
see.
area.
Two is
So if
the-
you think about it that way, yeah.
So,
And then you were talking about this minus right here. So that's going to be minus. That's the box component, right? So
Yeah.
it's going to be this times this and then times a distance of 10 because the center of the box on the x coordinate is 10 away from our point of reference. Yeah.
Sweet. And then you had number 7, I think.
Yeah, number 7 was a tough one, but we got through it. The answer is yes.
I still think it might be no, but I think I did some of the work wrong. It's yes.
You might want to go back and review that.
All right.
Thank you guys.
Thank you.
Peace out, Girl Scout.